Alright, so now we're going to check our crankshaft to determine if it needs to go to the machine shop. We have, on this crank, we have 3 main journals and 4 rod journals. When we check these journals, we want to take a diameter measurement on each side, and then again each side 90 degrees. When we check each side, we're looking for a taper or a slant wear in either direction. When we do our 90-degree diameters, we're looking for it to be out of round. As far as a spec for this, there is a spec, but it's basically no more than 1/1000th of an inch. So you want to try to be as accurate as you can, or as close as you can rather. See, which I can tell you, this crank is a still standard diameter crank. So our rod journal, let me grab my book real quick here. Our rod journal is going to be 2.297 to 2.298 inches. So if I take my caliper here, if you have a micrometer, you can use a micrometer too. Either one will work. And I take my caliper and I stick it right there. And that's the edge of the journal. We're reading 2.298. We'll come to this side. How the heck am I getting a 2.3 here? Okay. I was getting that 2.3 because I didn't have my caliper perfectly straight. So I spun it around so I can actually see it while I'm doing this, and I got 2.299. That's what I'm reading now. The whole way across. Caliper looks correct. Anyway, this crank's like ice cold because it's in my basement right now. That's something else you need to keep in mind. You need to have your measuring tools and your parts in the same atmosphere. That way everything's accurate. But anyway, each of these journals are correct diameter and taper, which, like I said, that's 2.298 for a standard crank. Now, if you see any kind of scoring here, then you're going to have to take it to the machine shop and be probably ground 10/1000ths under. As you see, my crank is pretty good and shiny, so there was no need for me to go to a machine shop. Your mains, you're going to check them the same way. You're going to do, your 2 tapered measurements and then your 2 tapers 90 degrees out to get your out of round. Your main, journal size needs to be 2.497 to 2.498. And let's see if I can get this one on camera. Well, you might be able to see it way over there. I got 2.495 going to this caliper. 2.496. about the easiest way to do this with a mic is to take and just set your measurement on the mic and then lock it in and then see what kind of drag you have. This is set to the rod journals. I don't know why this thing's fighting me today. But see, that's set to the rod journal size. And a lot of this is just done by feel. Because whenever it decides to go over it, it's perfectly straight due to these pads being so big. And you want a slight drag. It's like you don't want it to fall over it and you don't want it to be forced over it. So that's set to 2.498. And whenever I push it, it has a slight drag, so therefore that one's correct. Even though this one's telling me it's a little bit big. That's just the variations of the tools. So if you got multiple tools, it's a good idea to check twice. Okay, so now I moved my mic to 2, and I get the 2 because this is a 2 to 3 mic. So you get 2.4 plus 3 hash marks plus 23. So that gives me 2.498. And then same scenario. I just look for how much drag it goes over. And this one's actually kind of loose at 498, so it might be a 9.7, which is perfectly fine on spec, or tolerance if you want to call it that. Plus I do have a little bit of oil still on this crank from where I've done some other test fittings. But that's how you can mic your crank to determine if you need to go machine shop if you don't see any major scoring or anything. And one side note, you see how shiny this rod journal here is? It's like this one, I got oil on it so you can't really tell. But this journal had like some light scratches in it from just the rod wearing on it over time. I took some 1500 grit sandpaper and some WD-40 and I wrapped the paper around here and just taped it. And then I took my hand and just sat here and spun it. And that kind of brought a little bit of a polish to this. And that's all you really need to do. You don't want to put any rubbing compound or anything on it, because you want a little bit of a tooth here for oil to grab a hold of. If it's too slick, it just rolls right off, and you don't want that. But if everything's mic's out, then your crank's good. You can just shine it up a little bit, clean it up, put it back in your engine. And always make sure you clean out all these oil galleys. You know, the brake cleaner, compressed air, brushes, whatever you can get your hands on. Okay, so now to set up our rod bearing clearance, we're using a 2 to 3 mic, and we're going to set it at 2.298. If your crank has been cut, 10, 20, 30, whatever, you will subtract that from over here to add or to compensate for the machine distance here. Okay, so now we're going to set our dial bore gauge in here. And we're going to find our shortest distance on both of our y-axis and on x-axis. It looks like we're up here towards the top. That looks pretty good. So now we're ready to check the bearing clearance on our connecting rod. Okay, so check the clearance, the oil clearance in our rod bearings. First thing we gotta do is obviously install the bearings. Now for the 172, the cleavite number is a CB-535P. And if you need undercuts, it's just a dash and then the undercut number. Whenever you go to install these bearings, there's a hole in it and a keyway. There's a hole and a keyway in the rod. On your cap, there's just a keyway. However, both bearings, upper and lower, are the same. They even have the holes in both. So make sure you line all this up. Because that hole is actually going to shoot oil onto our camshaft. And just to go ahead and throw it out there, our pistons have an arrow on them that points towards the front of the engine. These rods can technically go either way in the engine, but we want this oil jet to point towards our camshaft. So that's how you know which way is forward or backwards if you get your rods mixed up. Well, another thing that can get you mixed up is this cap can technically go this way or this way, and it should still bolt on. However, your keys need to be on the same side and line up. So in the case of this one, there's a key here and a key here. So I'm going to take this cap and line my keys up. So now we're going to put these nuts on it, and we're going to torque them down. Torque spec for these is 45 to 50, so I just got it set to 45 right now. Okay, so now that our cap is torqued, we're now going to take our calibrated dial bore gauge, and we're going to stick it in here and see what our difference is. And there again, we're looking for our smallest measurement, which on this one, I'm running about 25 10,000ths of an inch. Get this over here so the camera can see it. See, that way it just gets higher and higher. Go this way. And of course it would be at the bottom of the frame. As you can see, our smallest measurement right there. Right about there, it's about 25 10,000ths of an inch. So that means that our oil clearance on either side is going to be roughly 1,000th of an inch, which is great. The rule of thumb for your rod bearings is to have 1,000th of an inch per pin diameter. So since our pin is 2 inch and we have 2,000ths clearance, this rod is great. So we should have excellent oil pressure on this piston, this cylinder, rod, whatever. And this is number 2. It's crazy. I actually filmed number 2 piston. I actually didn't plan that. Now the gauge will put a little scuff on these, like you can see there. It doesn't hurt them, but this piston or this rod is now ready to have the piston put on it.
Okay, so now that we got our rods bearings spec'd, and they all spec'd good, all of them checked anywhere from 25 10 thousandths to about 30 10 thousandths or 3 thousandths of an inch. So they're all within spec. So now we're going to do the main bearings. So have the number 1 in here right now. Each one of these main caps are different, so you cannot mess these caps up. The number 1 cap is the only one that's this size without a notch cut in it. The center cap with the thrust bearing has a notch cut out. It looks similar to this one, but it's got the notch. And the rear one is a big square one. I mean, it's pretty obvious on it. Each one of these main caps has an arrow that points towards the front of the motor. So now let's get these main cap bolts torqued. Torque spec's 100 to 105, and I got my wrench set to 100. Now, whenever you do the final install, I would recommend you stage torque this, which I'm just kind of pulling a little bit on one bolt and going back to the other. So I'm kind of stage torquing, kind of not. Okay, so that is torqued down. I have the dial gauge recalibrated for the mains. The service manual specs the main journals at 2.497 to 2.498. The 498 on mine felt loose, and the 497 went over them. So I set mine to 497. And we'll once again look for the smallest measurement. And this one's coming up to about 3.5 thousandths. So that's within spec. That's where we want that one to be. So now we know this front bearing is now good. So now I'm going to check the other two and make sure that they're within spec. Once they're within spec, the next thing I'm going to do is check the thrust on the crank. And you do that using these thrust bearings here. And we'll see if we have to sand them down to get any kind of thrust clearance or not. I can't remember if I had to do that on the 861 or not. So let me get them other two bearings checked for oil clearance and see where that puts me. Okay, so I got the other two main bearings in here. This main bearing had a clearance of 3.5 thousandths total. Rear one was 3.5 thousandths total. One in the middle was just under, or well, it's just over 3, about 3.2, 3.3 thousandths. So they're all great within spec. That low tolerance like that should give me great oil pressure. Now, the next thing I'm going to do in installing this crankshaft is I'm going to go ahead and check my thrust clearance, or my end-to-end play. But for starters, I'm just going to go ahead and put some assembly lube on here. I haven't installed the rear main seal yet because I'm probably going to be pulling this crank in and out. I'll put that in right before I'm finished with it, because I'm going to put that in, then I'm going to silicone this rear main cap. So technically I don't really need the assembly lube in here just yet for this step. I just kind of want it in here to act as a little bit of cushion on my crank when I go to set it down in there. So I probably won't put any on the main caps yet. Okay. Let's do a little wiggle test, make sure everything feels good. Now, the way that I check my main, or my thrust, I go ahead and bolt all the caps down. That way it's in there as if it was be running. And keep in mind your arrow goes towards the front of the engine. And right now on these bolts I don't really have anything lube wise. There's still some oil down in there from where the engine was taken apart. Whenever I go to put it back, I'll probably use some ARP Ultra Torque on them. So I'm not sure if the manual calls for anything or if they're to be dry or whatever. I'm not sure. But that Ultra Torque does just a nice job of making everything nice and smooth. Now, what I'm going to do for starters is the lowest this torque wrench will go is 50 foot-pounds. So I'm going to torque them for starters. All 6 bolts. Start from the middle and go out. I'm going to torque them all to 50 foot-pounds first. Okay, and then we're going to go to 100. And when you torque this stuff down, you want to try and do it in one smooth motion. Alright, just a quick check. Our crank spins nice and easily, which is great. That means our bearing tolerances were where they should be. Okay, so to check our thrust on our crank, or in play, whatever you want to call it, our spec is 2 to 6/1000ths of an inch. So as you see, I got this dial indicator set up here on the end of the crank. Zero this guy out. Now, what you want to do is either side of this center thrust bearing, you're going to take your big screwdriver, pry bar, or something, and just work your crank back and forth a little bit. And then you want to push it like all the way to the rear. Okay, so we're still zeroed. So now let's go towards the front. You should be able to see that gauge move back and forth a little bit as I rock this crank. So we have a little under 2/1000ths. Like I said, our spec is 2 to 7. I'm probably just going to leave that, in all honesty. I could take the thrust bearing out and kind of lightly sand on it some with some probably about 600 grit sandpaper and some WD-40. Like I say, mine's right under 2. My spec's 2 to 6. I may sand it a little, but if I do, it'll be very minimal. But that's how you check the end play, or thrust, if you want to call it thrust, of your crankshaft. And one other thing, be sure that whatever you've got your gauge set on is tight, because if there's any play here in your threads, that'll correspond out here. Best option will be to actually put this indicator straight on the crank, but I got that bolt in there from where I took it apart. I just haven't taken it out yet.